Hi folks, how's it going? Well, in this video, I'm gonna redo the last analysis that I've done. Just to recall, the last analysis was uh, regression of used car prices, which was part of a competition that happened on Kaggle last month. It already ended, and since I've done some changes on the analysis, I'm gonna show you those changes, and also I'm gonna do it this time from start to finish. So I'm not going just to focus on the data wrangling and the exploratory data analysis, but I'm gonna also show you how I performed the model selection, how I created the machine learning models, and how I performed the hyperparameters. So for this competition, I tried two different machine learning algorithms. First one was the random forest regressor, since this was a regression problem, and XGBoost regressor, extreme gradient boosting, which is one of the most widely machine learning algorithms used on the Kaggle competition. Is a quite robust algorithm. And as I said, I'm gonna do it from start to finish. So I'm gonna start by importing the relevant packages, importing the data, gather basic information such as descriptive statistics. Then I'm gonna perform feature engineering by dealing with missing values, performing a data feature extraction by extracting some specific text from some columns, and I'm gonna join an extended data that will enrich the analysis. Then I'm gonna show you how I prepare the data for the purpose of data visualization. So for the competitions, I like creating data visualizations using Power BI, which helps me to understand, and it's easily to create the visualization. So that's why, at least for the categorical variables, I like using Power BI to create the visualizations. And for the continuous variable, I use Matplotlib and Seabird to plot histograms, box plots, and scatter plots. So at the end, after all of that, I'm gonna perform the auto selection, perform hyperparameter, and model evaluation. So that's it. Let's get started. This is the competition's webpage on Kaggle, regression of used car prices. The goal of this competition is to predict the price of used cars based on various attributes. Those attributes are the brand of the car, the model year, the mileage, fuel type, engine, the transmission, external color, internal color, and there's the target variable, which is the price of the car. And as I mentioned, there is an extended data set that I choose to combine with this data set. So I'm going to show you the attributes of data set of this extended data and why I choose some of the attributes to enrich the analysis. So let's get started. Create an empty notebook. Let's just start by importing some packages for data viz and data manipulation. And let's import the datasets. Right? Input data. Well, let's check the first 5 rows of the training set. So as I mentioned, those are the values, attributes, values, model, model year, mileage, fuel type, engine. There are a lot of information here. Since well, there's the horsepower, the displacement, fuel type, which is already there, transmission, automatic, most of them are automatic, external color, internal color, accident, whether there is reported accident, claim title, uh, which means that the car has never been uh, considered total loss for the insurance. So it didn't have a severe accident. And there's the price in US dollar. Let's check the testing set. Oh, I forgot to import the testing set. Same columns except for the price, of course. Let's check the extended data. Well, here we have the this will be used as a unique identifier to join the dataset. So I have the model and the brand that I'm going to use to merge these two datasets. So what are the important attributes that I considered here? Miles per gallon, which we don't have here on the training set. Premium version, I'm not sure if it's relevant. This is the price suggested by the maker. I'm not sure about what MSRP means, but it's manufacturer. I think it's manufacturer sales recommended price. Manufacturer sales recommended price. And there's this collection called. I don't think that it's relevant for the analysis, but we can check that. Let's check the shape of the data. So 188,533 rows and 13 columns. Let's check if the data types are correct. So there are some missing values for claim title, accident, and fuel type. It seems all the data types are correct. I don't think that it is necessary to adjust the data type. Let's also check the data types of the extended data. There's also some missing values here. We might have to, if these null values are in the training data set, we might have to perform some